All right, so today we are looking at lesson 7-4. We're going to really look at properties of logarithms and how to use them to help us solve various problems or just to simplify logs, oftentimes with or without a calculator, more often without a calculator. So I'll be very clear as to when you can use a calculator and when you can't. So the product property basically says that if you have a log of any base and you have two things that are being multiplied, you can expand or tear that log apart, if you will, into two logs with the same base, but they're being added. And the vice versa is true as well. So if you have two logs that are being added and they have the same base, the things that you're taking the logs of can be multiplied together. The quotient property says that if I have a log of some base and I am dividing two things, that is exactly equal to taking the log of the numerator, got to use the same base, and subtracting the log of the denominator. And again, vice versa works as well. If I have two logs of the same base that are being subtracted, you can combine them into one log by just dividing what's being subtracted. Then we have the power property, and it says that if I have the log of some base, and I'm taking the log of something that is raised to a power, so I'm going to call that power p, then you can take this power right here and loop it in front of the log and multiply it to that log. So you would take the exponent, that power, and multiply it to the log base b of that item. So for instance, you might have log base 2 of 3 to the 4th, I don't know. And so what this says is I can take that 4 and loop it out in front, and I would have 4 log base 2 of 3. All right, and then there's the change of base formula, which is used mostly if you don't have a change of base in your calculator. So when you use that log button on your calculator, it's assumed that the log that you're taking out, so if you want to find the, you put in your calculator log 5, it's assuming that that's log base 10 of 5. So if you have a log that's a different base of 10, you can't use that log button on your calculator. So if you look in the math button or the math menu on your calculator, oftentimes calculators will have a, it looks like this, log base formula in that math menu. You just have to scroll towards the end. Oftentimes they don't have it, but neither here nor there, you still need to know how to find the change of base of a log. So if you have log base b of some number and you want to find its value using your calculator, you can take the log of m and divide it by the log of b. Now what I just did was I took the log of m right here and I divided by the log of b right here. Now I'm taking whatever this base is away and I'm creating a log with a base of 10. So it's understood that I have a base of 10 here and a base of 10 here. And so you would just put that in your calculator. So for instance, and this works for natural logs as well, but for instance, if you were doing, oh, let's use the example above, but I won't do the exponent. So if I have log base 2 of 3, you're going to take the log of 3, which is a base 10, and divide it by log of 2, which is a base 10, and you'll get the correct answer. So if you don't believe me, try finding this in your calculator underneath the math menu and put this in there and get your decimal equivalency, and then use the main screen on your calculator and just use the log button and put this in there. You will have to close parentheses. As soon as you put this in your calculator, it's going to do open parentheses here. You have to close those. And it'll do open parentheses here, and you have to close those. Just make sure you close your parentheses. Okay, so let's look at some problems using, and I do want to show you one more property. So if you have, let's make sure that I give you the right, so log base b of b, that's going to equal 1. And I'll explain this further in a minute. And then log base b of b to the x is going to equal x. And the reason for this is I'm going to show you, I'll get to an example where anytime you have the base and the log that you're taking of, if these are in agreement, your value for this is always 1. And I believe in one of the, I think the lesson 7-3, I kind of explained that, having log base 10 of 100. Maybe I did, I think. I can't remember. Anyway, I'll show you how this works when we go through a bunch of problems in here. So let's look at example 1a. If I'm going to do the first two, we are going to write this as a single log. Now, I would like you to write it as a single log and compress it. This is called compression, and we're going to compress it as far as we can go. So if we can come up with an actual number value, then we'll come up with a number value. If we can't, then we won't. So, for instance, your first step is to look and see I have this major operation going here, subtraction. So with our properties, if you have two logs that are being subtracted, we can work that backwards and say that this can be divided by this. So I can write this as one log base 2 of 32 divided by 4. So these two got combined as a single log, 32 divided by 4. So because division and subtraction go hand in hand in these properties. So I can actually divide 32 by 4, so I'm going to go further and write it as log base 2 of 8. Now, here's where I would like to go further. Technically, you've written it as a single log, and I'll accept that as an answer. But I can actually write 8 as 2 to the third power. So let's go further and take log base 2, and I'm going to write that 8 as 2 to the third power. Now, based upon some of our previous properties with exponents, remember I can loop that exponent in front, and I can write that as 3 log base 2 of 2. And also based upon my very last one that I gave you, this value log base 2 of 2, see how the base and the number are equivalent? That's going to have a value of 1. And so I really have 3 times a value of 1. And so if you wrote 3 as your answer versus this, I would actually accept both of those answers. Now, let's just look at this, and let me explain to you why log base 2 of 2 is equal to 1. Now that I have some real numbers there. So off here to the side, let's just examine that. If I asked you to evaluate log base 2 of 2, based upon what we did in lesson 7-3, we would start by putting it into exponential form. So the first thing that you would do would be to set this equal to x. Then the next thing you would do would be to put this into exponential form. So I'm going to keep my same base, so my base is 2, and I'm going to switch these. So I get 2 to the x is equal to 2. All I did was put this as my base and switch these. So I went from log form to exponential form. So 2 to what power is still going to give me 2? The only answer I can have for this exponent would be 1. So it doesn't matter what numbers I put here, 3 and 3, 10 and 10, a million and a million. You're going to have the same number here, so the only answer that this exponent could be would be 1. So that's why the log of anything, any base of that same number is always a value of 1. All right, so then let's look at B. So for B, when you have something in front of the log, before we can deal with this addition, and both of these have something in front of the logs, you need to unloop them. So the 5 got here because it used to be an exponent to the x. So this 5 needs to be looped back to becoming the exponent to that x, and the 3 needs to be looped back to becoming an exponent to that y. So I'm going to start off with rewriting those because you don't want anything in front of your log. And then plus of y to the 3rd. So again, the only thing I did was loop this back up so it became x to the 5th, loop this back up so it became y to the 3rd. Now you can deal with this big addition sign here. So if 2 logs are being added, then we can combine them to 1 log by multiplying these 2. So I end up with log base 4 of x to the 5th, y to the 3rd, and I oftentimes will just put parentheses around that. Now this one we cannot simplify any further. And by the way, you definitely don't want to re-loop this in front because first of all, these are raised to different exponents. So you can't just loop the 5 and loop the 3. It doesn't work that way. They would have to both be raised the same thing. And still, if we're compressing into 1 log, we still don't want anything in front of here. All right, so you go ahead and try C and D on your own. So pause the video, try your best at these, and then restart the video and check your work. All right, so the first thing I'm going to do is loop this 2 up to here. So I have log base 4 of 6 squared minus log base 4 of 9. There was nothing to loop there. And then you have a choice. You could either multiply this out to make it 36 and then deal with the subtraction. I think I'll go ahead and do that. My opinion is on these, the more work the better. Less in your head, more on paper. Kill that tree. So we get 36. And now finally, if I'm subtracting, I'm going to divide these 2. So I get log base 4 of 36 divided by 9. Well, 36 divided by 9 is 4. And in my opinion, your answer can be 1. I will also accept log base 4 of 4. But you know, and I would hope that you would start to get to the point where you know that that has a value of 1 because we need to get to there now so that we can use that in solving equations. All right, look at D. So for D, we have nothing in front that needs to be looped. We just have this addition. So we're going to take the 5x and multiply it to the 4x. So I have log base 3 of 5x times 4x, and you need to actually physically multiply those together. So I get log base 3 of 20x squared. Now you don't want to loop this 2 over here for 2 reasons. One, we don't want anything in front, but for 2 reasons, because this isn't squared either. I mean, it's not, I can't write this as something squared. Like for instance, if I could, like if I had log of, I don't know, base 3 of 25x squared, then I could write the 25 as 5 squared x squared. And now, because both of those are squared, I can write that as log base 3 of 5x squared. And then now I could have looped that back here if I wanted to. I wouldn't because I really want it as 1 log, but that's the only way that you can loop an exponent when you have multiple things here being multiplied out in front, is if everything is being raised to the same exponent, and here they're not. 20 is raised to the first power, x is raised to the second. So in our case here, this would be your final answer. All right, so let's go ahead and look at page 2 of your notes. Well, page 2. All right, so now we're going to expand. So we're going to do the reverse, and we're going to stretch out our logs into as many logs as it takes to break this apart. So the first thing that we want to deal with is this division. So division and subtraction go hand in hand. So this is going to equal log of, of 8x minus log of 5y. So the assumption is that the base must be 10 because I don't see it. If you want to put the 10 in there, feel free. Now on top of that, you've got multiplication going on here and here, but I want you to understand that you are subtracting everything that's going on with that log. So we've got to use parentheses, especially with that subtraction. You'll see why in a minute. So this can get broken apart with multiplication. It gets broken apart as addition. So this part, let me put that in green. So this part becomes log of 8 plus log of x. And then this part, if you recall, you've got minus, and I'm going to use parentheses. So I've got log of 5 plus log of y. And the reason for those parentheses is because we are subtracting all of this. So we have to subtract all of this. So this has to get distributed all the way through. And so our final answer is going to be log of 8 plus log of x minus log of 5 minus log of y. So there's your final expansion of those two logs. All right, let's look at this one. So for this one, we have division going on here. So that's the biggest thing we're going to deal with first. So this equals log base 4 of 32, and then minus, because of the division, log base 7, or not 7, log base 4 of 7. Now 32 can be written in exponential form. That's 2 to the 5th. So that's what we're going to do, log base 4, and instead of 32, I'm going to write it as 2 to the 5th minus log base 4 of 7. Now we can go ahead and loop this 5 into the front. And I get 5 log base 4 of 2 minus log base 4 of 7. All right, so that will be our final answer for that one. And that's a 4, hard to read. Okay, so what I want you to do is I want you to do C on your own, but wait for D for me. So go ahead and pause the video, try C, and then check your answer. Okay, so the first thing that we're going to look at is this multiplication that's going on here. We're going to stretch that apart first, then we'll deal with that exponents. So multiplication means we're going to add them. So log base 3 of 9 plus log base 3 of x to the 5th. So for your log base 3 of 9, you can change that 9, base 3, you can change that 9 into 3 squared plus, and then we can loop this 5 in front, and we get 5 log base 3 of x. So if you recall, if these are the same and there's an exponent here, the value of this log is just 2. Because if you loop that 2 in front, the value of this is 1. 2 times 1 is 2. So I gave you a shortcut that said that the whole value of that is going to be 2, and then plus 5 log base 3 of x. All right, let's see what's up with D. So with D, the ugly part about D is this square root here. But remember that we can write the square root of y cubed without the square root as an exponent. So let's deal with the fact that we have 4 times this. So because we have multiplication, I'm going to split that by addition. So log base 2 of 4 plus log base 2 of the square root of y cubed. Then 4 right here can be written in exponential form. So log base 2, 4 can be written as 2 squared plus log base 2, and then the square root of y to the third can be written with a fractional exponent. So remember that the index of this radical goes as the denominator here. So I can write this as y to the 3/2. So now I can do a couple things. Remember, this value right here has a value of 1, so it means that the exponent of 2 is going to be my answer there. And then this can loop in front, so I get plus 3/2 times the log base 2 of y. And then that is our final expanded form of that log. So let's look at the change of base formula. So I gave you the change of base formula, if you'll recall. I'm just going to write it here again as log, if you have base b of m, it's going to equal log of m over log of b. And that assumes that both of those logs will now have a base of 10. So I don't want you using the change in base formula in your calculator, because on a non-calc portion of a test, I would expect you to change this to log of 32 divided by log of 8. So even though we had started with a base of 8, we just take the log of 32 right here, assuming it's a base of 10, over the log of 8, assuming it's a base of 10. That's all we do. And then you're going to throw that in your calculator and calculate it. And so if you put that in your calculator, you're going to get a lovely decimal. And so we're going to squiggly equals, because we are going to estimate what that is. And so in our case, you're going to get, so we're going to get approximately 1.67. I rounded to 2 places. Okay? All right, so you try B on your own. So pause the video, try B. All right, so for B, you should be doing log of 18 divided by log of 4 is approximately equal to 2.08 if you round to 2 decimal places. All right, so let's look at this little bitty word problem. Word problems in this section are not necessarily my favorite, but we'll use them. Okay, so sorry it's small. So this is the formula that they have given you for the pH of a substance. You can find the pH by taking the opposite of the log of H+. And H+ is the concentration of hydrogen ions. In this case, in household dish detergent, is 10 to the negative 2. So the question is asking you, what is the pH level of the household dish detergent? So all we're going to do is plug this value right here in for H to the plus. So I have pH is equal to negative log, and it's assuming that the base of this log is 10 of, and I'm plugging in 10 to the negative 12. So I'm just going to really use my handy dandy calculator, but I don't even need to use a calculator here, because if this base here is 10, isn't the value of all of this 1? And so all I have to do is take this and multiply it to that negative that's out in front. And so I get a pH that's equal to positive 12. That's it. So of course you write a sentence, therefore, the pH level of household dish detergent is 12. All right, last page of notes. Now you're going to determine if the following statements are true or false, and you're going to use your properties. I highly suggest that you work just one side and try to make it look like the other side. Now I don't care if it's clearly going to be difficult for you to try to work 5 into looking like this. So if I were you, I'd attack the more complicated side first. So if I can condense this, meaning push it together into one log, and then evaluate that log and get it to be 5, then it's true. If I can't, then it's going to be false. So make sure that you get to the point where the left side equals the right side or the left side doesn't equal the right side, because that's how you're going to get your true or your false statement. All right, so I'm going to combine these into one log. So since we have a plus, I am going to multiply these two. So log base 2 of the 4 times the 8 is 32, is equal to 5. Then I can take this 32 and convert it into its exponential form. So I have log base 2, and instead of 32, I'm going to write it as 2 to the 5th, and then equals 5. And then we know that this value here is equal to 1, and I gave you another property that said if that's the case, whatever the exponent is, that's the value of that log. So 5 in this case does equal 5. So since I did get the left side to equal the right side, this is true. And when it says to verify, this is your verification right here. All right, so try B. See if you can, this is the more complicated side out of the two. See if you can combine this side and make it look like this side. Don't force it, because it may or may not be true. So pause the video and restart it. Okay, so because of the subtraction here, I'm going to divide the 16 and the 2. So log base 4 of 16 divided by 2 is equal to log base 4 of 14. Well, 16 divided by 2 is 8. And at this point, there is no possible way that I can make 8 into 14. So this is going to be a not equal to statement. So this is going to be a false statement. Then our final problem is going to be a word problem. Joy of all joys. All right, so make it even smaller. All right, there we go. So in this particular problem, we're going to highlight some things that are important. So we start off with the brightness of stars is measured on a logarithmic scale called magnitude. So this is your magnitude here. The relationship between the ratio of apparent brightness of two objects and the difference in their magnitudes is given by this formula here. So that's an important formula. So we're going to need to use that. And then they go and describe what the parts are in this formula, where M is the magnitude, so there's two different magnitudes, and B is the apparent brightness, so those are your two different apparent brightnesses. Then they go on to say that the star of Capella has a magnitude of 1/10, and the star Regal has a magnitude of 12/100. So we have two different magnitudes. The question is, how many times brighter is Capella than Regal? To do that, we need to get this ratio of B sub 2 over B sub 1 to get on one side of the equation by itself, because this ratio of brightnesses is going to tell us how many times brighter Capella is than Regal. So let's start off. I'm going to use our 4-step plan, and we're going to let, we'll do M sub 1. Actually, I want the, since we want Capella to be brighter, I'm going to let M sub 1 is going to equal Regal. So that's a 0.12. So that's your Regal, or however you say that. And then M sub 2 is going to be Capella. Okay? Then let's plug into our formula what we know. We only know those two things. So for M sub 2, which comes first, I'm going to put 0.1 minus M sub 1, which is 0.12, and that's going to equal negative 2.5 log. I'm just following the formula. It's a base 10, and we don't know B sub 2 or B sub 1. So if I want to get this by itself, this log by itself, the first thing that I need to do is subtract these two values, and then I'm going to divide by this. and then we'll talk about it from there. So 0.1 minus 0.12 is negative 0.02 equals negative 2.5 log b sub 2 over b sub 1. Then I'm going to divide this side by negative 2.5 and divide this side by negative 2.5. And we get on the left positive 0.008 equals log of b sub 2 over b sub 1. So my goal is to get this by itself because, again, that ratio is going to tell us how many times brighter Capella is than Regal. And because they said Capella is than Regal, that's why Capella became the sub 2, because that's the one that we're trying to figure out which is brighter. So if I'm going to try to get this by itself, I like to write my logs so they're on the left, so I'm going to flip this. To evaluate this log, I don't know what I'm taking the log of, but I know for sure that I have a base 10. And so I want to write this in exponential form. So I'm going to keep the same base, and then I'm going to swap these two. So if I swap those two, I end up with 10 to the 0.008 should equal my ratio of brightness of Capella to Regal. And so then you're going to have to use your calculator and actually find out what is 10 to the 0.008. And so you get approximately 1.01859. So, so I'm losing my voice. Therefore, just restate the question as an answer. Therefore, Capella is about, because we have to round, and I'm going to round to 3 decimal places, so I'm going to round to this 3rd place, so I have to look at the 5 next door, so it bumps the 8 up to a 9. So Capella is about 1.019 times brighter than Regal. And that's it. Have fun on your homework. Ask me questions.